Good evening, everyone. I'm Pranav Ashok Mahitkar, a third year mechanical engineering student at IIT Madras. And the project that I'm working on is wind and rain driven ambient noise layer for the Indian Ocean region. So, the goal of the project is to build the natural acoustic baseline for the IOR, or in other words, you can say that we are building a model by which we can calculate how much noise is generated in the ocean due to wind or rainfall. Region is one of the world's strategically and ecologically critical bodies of water, yet its underwater soundscape remains poorly understood. Most regional ocean planning treats underwater noise as purely anthropogenic, focusing entirely on commercial shipping. The national noise score, that is, the noise generated due to wind and rainfall, is entirely unmapped for this region. So, and without this baseline, it is impossible to assess how much extra noise the vessel traffic adds and where the biologically sensitive quiet zone exists. So, the outcome of this project is a 3D ambient noise layer with a 12-month climatology delivered as separate wind and rain modules and then integrated into the MSP toolkit. There are various stakeholders and beneficiaries for this project. The naval and defense forces can use this for submarine operations, mine countermeasures, and maritime domain awareness activities in the IOR. Hydrographic organization can use this for climate products and navigational safety assessment. Conservational bodies and ENGOs can use this to identify seasonally shifting acoustic quiet zones, which are critical for noise-sensitive marine species. Marine spatial planners can use this as a plug-and-play ambient noise layer for the MSP toolkit. And this project can also be used for research and scientific purposes, as well as shipping and port management. So the unique features of this project is first, this is the first IOR-specific natural noise baseline. Second is dual source separation. The wind and the rain are modeled independently, so the user can analyze uh, each source separately. Third is monsoon-aware seasonal climatology. Fourth is these models are based on equations from research papers by renowned scientists like Hildebrandt and Newton. And fifth is plug-and-play integration into the MSP toolkit. So the methodology project is step one was literature review. We went through a number of research papers to gather the required knowledge and the necessary equations. Step two was the collection of multi-data set acquisition, uh, like ERA5 reanalysis for the speed of wind and NASA GPM for the precipitation rate, etc. Step three was the spatio-temporal alignment. So we have interpolated all the data set to a common 0.25 degree master grid. Step fourth is acoustic modeling. For the wind layer, we are using Hildebrandt's empirical equation, and for the rain layer, we are using Newton's empirical equation. And the step five was to generate a 12-month climatology and to capture effects of southwest and northeast monsoon, and then integrate this into the MSP tool. So this is the equation that we are using for the wind model, and this is the equations that we're using for the rain. So we have integrated both of these models, the wind and the rain, into the MSP toolkit. And the planner can toggle a wind noise or rain noise layer and then adjust the month, depth, and frequency and generate an interactive noise map. These are some of the results from the wind model. So on the left side, as you can see, the noise generated due to wind in the month of July is considerably higher than the other months. And this is due to the presence of southwest monsoon. Some other results are this. This is the comparison between the noise generated by the wind in the ocean in the northeast monsoon season and the southwest monsoon season at a frequency of 500 hertz and a depth of 100 meters. This is the result for the rain model, a comparison between noise generated by rain in the southwest monsoon season and the northeast monsoon season. And this is the July snapshot. If you look at this image, you will see that this represents the noise generated due to rainfall in the month of July uh, at 5 kilohertz frequency and 0 meters depth, which means the surface of the ocean. The user can generate these kind of noise maps for wind as well as for rain for different months at different frequency and at different depths. And by these noise maps, we can have different or very useful insights regarding the ocean. And in the conclusion, I would like to highlight that this project provides value on three aspects: the planning value, the ecological value, and the strategic value. By combining the raw weather data into the living acoustic map of the Indian Ocean, which will enable smarter, science-based, and sustainable ocean governance. That is it from my side. Thank you.